Hello coders, I welcome you all. In this video, we are going to discuss our next NLP project, Natural Language Processing project, Automated Text Summarization using NLP. In the NLP journey, this project holds its own importance. Now let's begin with a simple introduction to our project. Imagine you have watched a long movie and someone asks you what it's about. Instead of recounting every scene and detail, you would likely summarize it by highlighting the main plot points, key characters, and significant events, right? This summary gives others a quick overview of the movie's storyline without needing to watch the whole thing. Text summarization works similarly. Text summarization is like telling someone the main points of a story or a book without going into all the details. It's about capturing the key ideas and presenting them in a shorter and more condensed form, making it easier for people to understand the main message without reading the entire text. Applications of text summarization. Text summarization with NLP finds applications in news, document, email summarization, social media monitoring, content curation, legal analysis, education, customer feedback analysis, medical records, and meeting summaries. Now let's move on. In NLP, there are two types of text summarization that we can implement: extractive text summarization and abstractive text summarization. Now let's first discuss extractive text summarization. In extractive text summarization, the summary is created by selecting and extracting important sentences or phrases directly from the original text without any modification. I am repeating, in extractive text summarization, the summary is created by selecting and extracting important sentences or phrases directly from the original text without any modification. Now let's discuss abstractive text summarization. In abstractive text summarization, the model generates a summary by understanding the original text and paraphrasing it in a concise manner, possibly using new words or sentence structures. I am repeating, abstractive text summarization. In abstractive text summarization, the model generates a summary by understanding the original text and paraphrasing it in a concise manner, possibly using new words or sentence structures. As you can see here, I have implemented two GUIs, one for extractive text summarization and another for abstractive text summarization. Now let's use our first GUI that you can see over here for extractive text summarization. Let's input text inside the text input. So this is our text input, and here we will see the output after extractive text summarization. We can also select number of sentences that we want in extractive text summarization. So here the text, let me copy this and let me paste it over here. We want 3 sentences in extractive text summarization. So that's why here I have selected 3. Now let's press this button, summarize. As you can see, the output consists of 3 sentences because we have selected 3 here. You can select as per your requirement. Please remember, this GUI performs extractive text summarization, meaning it internally identifies important sentences based on their scores. Don't you worry, we are going to implement this shortly. And here it directly prints the top 3 sentences because here we have selected 3 from our paragraph without any modification based on their scores. So as we discussed, in extractive text summarization, the summary is created by selecting and extracting important sentences or phrases directly from the original text without any modification. Now let's use our second GUI. Let me close this. As you can see, this is our second GUI, which performs abstractive text summarization using a transformer. Let's input the same paragraph and let's press this button, summarize. As you can see here, the abstractive text summary. Please remember, these sentences are not directly taken from the original text. So as we discussed, in abstractive text summarization, the model generates a summary by understanding the original text and paraphrasing it in a concise manner that you can see over here, possibly using new words or sentence structures like ChatGPT. Don't you worry, we are going to implement this both, extractive text summarization and abstractive text summarization. And let's write code for extractive and abstractive text summarization. Now let's jump to Jupyter Notebook And let's write code for extractive and abstractive text summarization. Now let's start with extractive text summarization first. Then we will discuss abstractive text summarization using transformer. So in this first method, extractive text summarization, we will use sentence importance to generate the extractive summary of the input text. First, we will tokenize the text and identify the occurrence of important words. Then we will calculate the importance of each word. Next, we will assign weights to sentences based on the sum of the importance scores of their words. Finally, we will rank the sentences and select top n sentences from the text body to form the summary. Don't you worry. Shortly, you will understand everything. Now, let me copy this text and let me paste it over here. So imagine you have a big chunk of text that you can see over here, like a long story or article, and you want to make it shorter while keeping all the important parts. That's what we are going to do here. We start by putting the long text into a variable called text that you can see over here. And here is the text that I wrote, which we will use for text summarization. And I have stored it in the variable text that you can see over here. Now let's execute this cell. Now first, let's count the characters in our text using this length function. As you can see the number of characters in our text. So now let's import libraries that we require. We will import others when they are needed. So first, we require spacey. Also from spacey dot lang dot en dot top underscore words, let's import stop words. And also from string, let's import punctuation. Let's execute this cell. So we are going to use these two libraries for text cleaning. Now let's import the small sized English model from spacey. So we have to write spacey dot load, and here en underscore core underscore web underscore sn, and let's assign it to one variable NLP is equal to this statement. Let's execute this cell. So now let's apply the loaded pre-trained model to our text stored in the text variable, this one. So here we have to use this instance NLP that just we have created, this one. And let's apply this pre-trained model to our text, this one, that we have stored in this text variable. And let's create one variable with name doc. Let's execute this cell. Now let's write code for tokenization and removing stop words from our text, this one. So here I am going to use list comprehension. So for token in doc, first let's print token dot text. We are extracting text from the token, and let's convert into lower case. So here we are printing lowercase version of the token if token dot is underscore stop. So print the token if it is not a stop word, and not token dot is underscore punct. Print the token if it is not a punctuation mark. Also token dot text not equal to new line. Let me assign it to one variable tokens is equal to this statement. Let's format it out. So this code performs tokenization and removes stop words from the processed text. So we first process the text using loaded spacey language model here, which we have stored in the separate variable doc. Then we iterate over each token in the document that you can see over here. For each token, we check if it is not a stop word, not a punctuation mark, and not a new line character. If the token meets these three conditions, we convert it to a lower case and add it to the tokens list, this one. So this process effectively filters out common words like the or is, punctuation marks, and new line characters from the text, leaving us with a list of meaningful words only. Let's execute this cell. Let's check. As you can see over here, our clean text without stop word, without punctuation mark, and without new line character that you can see over here. So this is the first way by that we can perform tokenization and text cleaning. So now let's discuss alternative approach to removing stop words and punctuation using POS tagging, part of speech tagging. Let me write the code first, then we will discuss. So let me create one empty list and also list of stop words that we have imported over here. This one, stop words. and let me assign it to one variable stop words is equal to this statement allowed underscore POS. So we want only this tag. Now for token in doc, if token dot text in stop words or token dot text in punctuation that we have already imported, this one from string, then continue. If token dot POS underscore in allowed underscore POS, this one, then tokens one dot append token dot text. Let's execute this cell. Let's check. As you can see over here, our clean text. So as you can see here, alternative approach to removing stop words and punctuation using POS tagging. So as you can see here, we initialize an empty list named tokens1 to store the filter tokens. Here we have created a list of stop words using the predefined set of stop words from Spacey that we have already imported. And here you can see another list of allowed POS tags, including adjectives, proper nouns, verbs, and nouns. And here we iterate over each token in the processed document, doc. And as you can see here, if the token is in the list of stop words or is a punctuation mark, we skip it using this continue statement. And here you can see another if statement. If the token's POS tag is in the list of allowed POS tag, this one, we append it to the tokens one list, this one. So this is alternative approach for removing stop words and punctuation. Now let's move on. So as you know, currently we are performing extractive text summarization. So our main goal is to find the sentences that have the most important words in them by focusing on sentences with the keywords appearing most often. We create a summary that captures the main ideas of the original text. So let's get started. So let's calculate the frequency of each word in the list of tokens using the counter class from the collections module. So first we have to import from collections. Let's import counter. Let's execute this cell. Now let's calculate word frequency. So counter, and here we have to pass tokens. So currently we are considering this code. You can consider this or this, anyone. Let's execute this cell. As you can see over here, Python dictionary. As you can see here, this particular word, kindness, occurs 5 times. Power occurs 3 times. Likewise, that you can see over here. So we have successfully calculated word frequency, and let's assign it to one variable. Word underscore FREQ is equal to this statement. You can give any other name as well. Let's execute this cell. So please remember, the counter class is a convenient tool for counting the frequency of elements in a list or any iterable. So as we have seen, this line of code creates a dictionary called word underscore frequency that stores the frequency of each word in the list of tokens, right? This one that you can see over here. And as you can see, we have utilized the counter class from the collections module to efficiently count the occurrence that you can see over here. As you can see here, this particular dictionary word underscore frequency contains each unique word from the tokens list as a key that you can see over here, with its corresponding value being the number of times it appears in the list. As you can see here, key value pair, word and number of times it appears in the list that you can see over here. Now let's find maximum frequency. So max word underscore frequency dot values. We want to find maximum values from values, and here max underscore frequency is equal to this statement. Let's execute this. Let's check. As you can see here, maximum value is 5 that you can see over here. This one. So now let's normalize these values. For that, let me write for word in word underscore frequency dot keys, and word underscore frequency word as a key, and word underscore frequency and the word divided by max underscore frequency. Now let's check. As you can see here, normalized value. So as you can see here, this loop iterates through each word in the word frequency dictionary keys and normalize the frequency of each words by dividing it by the maximum frequency. In our case, 5. So this normalization process scales all the word frequencies to be between 0 and 1 that you can see over here, ensuring that the most frequent word has a normalized frequency of 1 that you can see over here, and while less frequent words have a lower values that you can see over here. So just here we have performed normalization, nothing else. Now let's move on. Now let's perform sentence tokenization. So for that, I'm going to use list comprehension. So for sent in doc sends, and let's extract sentence text. Let's assign it to one variable. Sent underscore token is equal to this statement. Let's execute this cell. Let's check. As you can see here, this is our first sentence. This is second one. Likewise, as you can see here, now this sent underscore token is a list where each element represents a sentence from the original text that you can see over here. Now let's write logic to calculate sentence scores based on word frequencies. So for that, sent underscore score dictionary. So here I am creating one empty dictionary. So for sent in sent underscore token, let's print word from each sentences, because we are going to calculate sentence scores based on the word frequencies. So that's why here we are extracting word from the sentences. In sent dot split, let's check word. Let's execute this cell. As you can see here, words from sentences. Now let's implement our actual logic to calculate sentence score based on the word frequencies. So here, let me write if word dot lower in word underscore frequency keys. So here we are checking word underscore frequency keys. This one. So if sentence not in sent underscore score dot keys. So in this particular dictionary, if sentence not in sentence score keys means if sentence is not available as a key in this particular dictionary, then let's use this dictionary and sent, and also word underscore frequency and word. Else sent underscore score sent plus equal to word underscore frequency underscore word. So here we are extracting word frequency for this particular sentence. So in this case, our sentence become key in this particular dictionary, and word weightage, this one that we have normalized, will become values. So now let me explain you this code. So as you know, this line initialize an empty dictionary named sent underscore score, which will store the scores of each sentence. Now this line, this loop iterates over each sentence in the sent token list, which contains the individual sentences from the text. This one. Right? That just we have created. Now this line, for word in sent dot split, this nested loop splits each sentence into individual words and iterates over them. Now this if statement, if word dot lower in word underscore frequency dot keys. So this condition checks if the lowercase version of the word exists as a key in the word frequency dictionary. This one. Ensuring that we are only considering the words that have a frequencies calculated. Now next, if statement. If sent not in sent underscore score dot keys, this condition checks if the current sentence is already in the sent score dictionary as a key. Then it will execute this statement. So if the sentence is not in sent underscore score dictionary, this line creates a new entry in the dictionary with the sentence as the key and assigns the frequency of the word as its score. Else, this one, if the sentence is already in the sent underscore score dictionary, this line increments its score by adding the frequency of the current word. By end of this process, sent_score dictionary will contain the score for each sentence in the text, calculated based on the frequency of the words within each sentence. Let's execute this cell. And now let's check this dictionary. Let me copy this and let me paste it over here. Let's execute this cell. As you can see over here, score for each sentence that you can see over here. Now let me show you properly. Let's create pandas data frame. So import pandas as pd and pd.data frame list our dictionary sent_score dot items and columns as sentence, and here another column score. Let's execute this cell. As you can see over here, sentence and score. So as you can see, we have successfully calculated sentence score based on word frequencies that you can see over here. This is first sentence with score. This is second sentence with score. Likewise, that you can see over here. Now let's move on. As you know, currently we are performing extractive text summarization. So let's select the top scoring sentences based on their scores calculated here that you can see over here. We are going to select top scoring sentences as per their score, this one. So for that, let me import from heap queue. Let's import n largest. Let's execute this cell. Now here, let me create number of sentences 3. You can select any. And let's use n largest. First argument, number of sentences that we want to select as per sent_score. And here key sent_score dot get. Let's execute this cell. As you can see over here, top 3 sentences based on their score that you can see over here. As you can see here, small acts of kindness. As you can see here, having the highest score 3.6. This is our second sentence from grass roots. This one having the second highest score 3.2. And whether it's a smile to a stranger, this one that you can see over here. As you can see here, 3 sentences with similar score 3.0, 3.0 and 3.0. But first one is displayed, this one only, because we have selected only 3 sentences that you can see over here. Now let's join these sentences. Let me assign it to one variable and let's join. And as you can see over here, now it's look better, right? So this way we can perform extractive text summarization. As we discussed in extractive text summarization, the summary is created by selecting and extracting important sentences or phrases directly from the original text without any modification that you can see over here as per the sentence score that you can see over here. Therefore, these sentences are directly taken from the original text without any modification based on their score that you can see over here. So this way we can perform extractive text summarization. Now let's discuss abstractive text summarization. So for that we have to use transformers. Now let's move on. As you can see here, I have created GUI for extractive text summarization. So user can perform extractive text summarization using this GUI. So let me copy our text and let me paste it over here. Here you can select number of sentences as per your requirement. Let's keep 3 here and let's press this button. As you can see over here, this one. So this way we can perform extractive text summarization. Now let's move on. Now let's discuss abstractive text summarization. So for that we have to use transformers. So as we discussed earlier, in abstractive text summarization, the model generates a summary by understanding the original text and paraphrasing it in a concise manner, possibly using new words or sentence structures. So here to perform this abstractive text summarization, we are going to use transformers. So let me give a short introduction to transformers. So when you search on the Google regarding transformers, you will find this figure that I am directly using from Google. So transformers are a type of deep learning model that has transformed natural language processing and various other tasks in machine learning. They are called transformers because they work by transforming input data through multiple layers of computation. Unlike earlier models that processed input data sequentially, Transformers use an architecture that you can see over here called the transformer model, which allows for parallel processing of input data. This architecture that you can see over here is composed of two main components, the encoder that you can see here and the decoder. The encoder processes the input data such as a sequence of words in a sentence and transform it into a format that captures the relationships between the words. The decoder then takes this transformed representation and generates an output, such as a translation of the input sentence into another language. One of the key innovations of transformers is the self-attention mechanism, which allows the model to focus on different parts of the text data when processing it. This mechanism enables transformers to capture long range of dependencies in the data more effectively. Compared to previous models, transformers have achieved remarkable success in various NLP tasks, including language translation, text summarization, sentiment analysis, and question answering. They have become the foundation of many state-of-the-art NLP models such as BERT, GPT, and T5, and continue to drive advancements in the field. So now let's perform abstractive text summarization using transformers. Now let's jump to Jupyter Notebook back. Now let's import pipeline from transformers. So from transformers, let's import pipeline. Let's execute this cell. So as you can see, we have successfully imported pipeline from transformers. Please ignore this warning. Now let's use pipeline. Here we have to write summarization because currently we are performing abstractive text summarization. And next we have to give model. We are going to use T5 base. Also another argument tokenizer. Again T5 base. And here another parameter framework PT. Let's assign it to one variable summarizer is equal to this statement. Let's execute this cell. Please ignore this warning. So as you can see here, first we have imported pipeline from transformers library. This function enables easy access to pre-trained models for various NLP tasks. So please remember, here we have used this pipeline function from the Hugging Face transformers library to create summarization pipeline. And here we have created summarization pipeline. Here you can see summarization argument specifies that we want to create a pipeline for text summarization, abstractive text summarization. Next is model. As you can see here, model T5 hyphen base and also tokenizer T5 hyphen base. So these arguments specify that we want to use the T5 text to text transformer model and tokenizer for summarization. And here in our last argument, we are using framework PT. So this argument specifies that we want to use PyTorch as the framework for running the model. Now let's move on. Now again, let's copy our text to summarize. And we have to use our created summarizer, this one. And here we have to pass our text that we want to summarize. Max underscore length is equal to 100. Mean underscore length to 10. And do underscore sample to false. Let me assign it to one variable summary is equal to this statement. Let's execute this cell. It will take some time. We have to wait. Now done. As you can see here, first argument is text. This is the input text that you want to summarize. Max underscore length is equal to 100. This parameter specifies the maximum length of the generated summary in terms of tokens. Mean underscore length. This parameter specifies the minimum length of the generated summary in the terms of tokens. And we have set do underscore sample to false. This parameter controls whether sampling is used during generation. Setting it to false means that the model will not use sampling and will instead choose the most probable tokens at each step. So the summarization function will return a list containing the generated summary. Let's check that you can see over here. Now let's print the summary into a proper format. Summary 0, and we have to use this key, summary underscore text, this one. Let's execute this cell. As you can see over here, our abstractive text summary. So this way we can perform abstractive text summarization using transformer. So as we discussed, in abstractive text summarization, the model generates a summary by understanding the original text and paraphrasing it in a concise manner that you can see over here, possibly using new words or sentence structure that you can see over here. These sentences are not directly part of our original text. This one. This is called as abstractive text summarization that you can see over here. So this way we can perform extractive and abstractive text summarization. So now let's move on. As you can see, also have created GUI for abstractive text summarization. Let me show this. So this is our second GUI. Using that, we can perform abstractive text summarization. Now let's take our text. Let me copy this and let's give as an input to our transformer. Let's press this button, as you can see over here. So using this GUI, user can perform abstractive text summarization. So this way we can perform extractive text summarization and abstractive text summarization. Let's revise it. In extractive text summarization, the summary is created by selecting and extracting important sentences or phrases directly from the original text without any modification. But in abstractive text summarization, the model generates a summary by understanding the original text and paraphrasing it in a concise manner, possibly using new words or sentence structures that you can see over here. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.